in my view, a massive changes is the connectivity between machines. So far, it's all human-centric. It's all social media. It's all people using the internet for YouTube and all the video sharing, and that consumes a lot of data. But we'll see in the future machines that do exactly their social media as well, but at data rates even higher.
Last 3 decades, we've seen the transition from telephones, landlines, to wired internet, to Wi-Fi. Today in India, we have 1 GB of data available for as low as 10 rupees. However, when we're talking about the world steering towards a metaverse, where education, every form of interaction is primarily online, existing amounts of data and existing speeds of internet are not good enough. And the technology that we have today is not good enough to meet these requirements either. But we might have a solution. The key to getting gigabits of data per second without any geographical constraints might be LiFi. In today's conversation, we have Professor Harald Haas, who is a professor at the University of Edinburgh and a fellow of the Royal Society of Edinburgh, who is also the inventor of LiFi, and he founded this company called PureLiFi to scale this technology across the world. In this conversation, we speak about what the future of communication and connectivity would look like. What are the opportunities for students, entrepreneurs, governments, and other stakeholders to participate in the space? How should future of connectivity look like where geographical barriers aren't a constraint? That is, how do you have connectivity in the remotest regions of the world, in mountains, in valleys, in forests? And how LiFi might be our stepping stone towards realizing these ambitious connectivity dreams that seem just out of a sci-fi movie. So wear your thinking caps and listen to this conversation with Professor Harald Haas on Curiously with KVK. Hi, Professor Harald. Thanks a lot for agreeing to be on the podcast. For the viewers, LiFi is one of the groundbreaking technologies that's potentially the future of how we would communicate information through the internet. And Professor Harald is one of the inventors of LiFi. So the first time I actually got to know about LiFi was when I landed on a tech talk that you had given back, I believe, in 2011 and 15. And this got me really intrigued, and I wanted to study more about this domain and understand what this future is all about. So thanks a lot for being here, Professor Harald. Do you want to maybe start off with a small introduction on how you ended up pioneering this idea and trying to work at the intersection of light and communication?
Thank you, Krishna, and first of all, thank you very much for inviting me today to this podcast, and I'm delighted to be here. Thank you. So first of all, my background is I'm a wireless communications engineer, and I've worked in the industry for 25 years, starting off with the second generation of mobile communications. I worked for Siemens Semiconductors, which later become Infineon, developed chipsets for GSM, second generation, as I said. And I've been in radio comms for a long time of my career, and have changed the gears from radio to optical wireless when I basically entered academia in 2002, where we then looked at alternative means of transmitting huge amounts of data. And at that time, the white high bright LED came out, and that we saw as an ideal vehicle to explore new ways of wireless communications. And that's not something completely new, because there were people in Japan, Professor Nakagawa, who did that at Keio University. But we really wanted to build networks with light and using current infrastructure in your homes. All your LED lightings should become data transmission. So that is where we were intrigued, and we developed basically projects, curiosity-driven projects, and then we moved from strength to strength. And I'm delighted now. I'm leading the LiFi Research and Development Center at the University of Strathclyde in Glasgow in the UK, where we basically develop all sorts of new technologies around visible light communication and LiFi. But I also founded PureLiFi in 2012, where this company is commercializing some of that technology already now into the markets. So very, very exciting journey. And I've enjoyed walking between academia and entrepreneurship. And that's really an exciting path, I found.
That's lovely, Professor Harold. So, as part of a longer decade, I think you've spent close to 2 decades at the intersection of light and communication and building networks of how do you communicate using light as a technology potentially.
That's correct.
So at what stage are we at when it comes to LiFi? Is it ready for use, or is it still undergoing transformational research stage, or has it already be translated into commercially available, usable formats?
I think it's a very exciting time, and some people say why it's not taking up by the markets, but we have to realize that things need time to mature and become ready for the markets. And however, the direction and the way things are going at the moment with exciting new applications such as AR and VR, such as digital twins, so where we really want to map our physical world into the cyber world. And if you think about the autonomous systems, the cars on the road that are autonomous, these are all big challenges, big goals. But if you look at AR, VR, it's still connected. It's still a cable that provides you the connectivity because of the huge data rates you require and the low latency. Do you see autonomous cars? No, not really, because there's been issues around autonomy. Do you see digital twins? No, because it is, people want to build AI, machine learning, and to drive all these things, but it doesn't suffice to have a brain that maybe have the processing powers, but you don't have the nervous system to basically connect to your sensors and connect to your actuator. So connectivity is one of the major barriers for driving innovation with exciting new products that really make a difference, rather than marginal improvements on your smartphones that you see here and there. I mean, looking at increased megapixels of your camera, that's not the end of innovation. I think there's much more to come here, and connectivity is at the core of such innovation that has to be recognized. It's not only the algorithms; it's also the nervous system, the connectivity that need to be developed in advance. And the visible light spectrum has 2,600 times more unregulated free bandwidth than radio, and that's a fact. And now really is to develop the technologies that make use of that potential is what is key.
Okay, so when we're talking about connectivity, are you trying to say that LiFi allows for higher bandwidth and potentially longer ranges of connectivity?
That's correct. It's used for indoor application for access, but also for long range point-to-point free space optical communication. And I always compare it is if you have a single track road, you can have a certain amount of traffic that goes over a single track road. But if you have a highway with 2,600 lanes, you have much more traffic and much more vehicles that could go over that big highway. And a vehicle is a packet in my analogy. So that's really unlocking huge amount of additional data packets flows with light, and that's again unregulated spectrum.
Very interesting. So could you maybe explain how exactly LiFi works? What is it about LiFi that allows for such high bandwidth and such high longer ranges of connectivity?
That's an excellent question as well. But what I would like to add here as a precursor is light is part of electromagnetic spectrum. It's radio is part of electromagnetic spectrum. So radio and light all have the same properties physically. They are sort of electromagnetic waves, and if you go to higher frequencies, you can argue they are particles, photons. But it's fundamentally the same physical domain, if you want, and therefore it is possible, if you can transmit data with radio, you can transmit it with light as well. So how does it work? Essentially, is we take light waves and we encode information into a light wave, a binary information, digital information into light waves. And the easiest way you could do it, essentially, if you want to transmit a binary stream of data, zeros and ones, you take a light source, your light bulb in the ceiling, you turn it off. When you transmit a binary 0, you turn it on when you transmit a binary 1. And if you do it so fast, really fast, then the human eye would not see any flicker. So you transmit a binary bit stream by turning on and off. That's the easiest way, but certainly not the way we have been doing research and have encoded data for the last 20 years. It's more subtle, more technically involved than this, but it's a principle of changing the intensity in a way to encode lots of information into that change of intensity. That's why I can use any light source. And in fact, that people didn't really use high-speed comms prior to the solid-state lighting age is because incandescent light bulbs are essentially heaters. And to turn them on and off, it takes a while to cool down and it takes a while in order to heat up. So the data rates are very low, whereas with LEDs and lasers, they can be switched extremely fast. And that's something that we've exploited.
Got it. So it's primarily the frequency of this particular kind of electromagnetic waves that allows us to have this leverage as opposed to, let's say, radio-based communication. And am I right in saying that?
Essentially, yes. So there's one very simple method that with on-off keying, it's called intensity modulation direct detection.
Sure.
So we change the frequency of the intensity. We don't change the light wave itself.
Okay.
We change the frequency of the intensity variation, and that's how we can encode data with light.
Got it. So what's actually preventing us from bringing this to mainstream adoption in all our homes and offices and workspaces?
So first of all, and I need to say that that technology is already applied in various verticals right now. For example, in defense, this technology is used for defense applications simply because of the fact that LiFi is not detectable outside, say, a room or some space that has opaque sort of covering. So radio goes through walls, right? It goes through wood, for example. It goes through cotton and other materials. The radio waves go through this. Light doesn't go through opaque materials, so it stays where it is. And therefore, if you have basically tactical operations on the ground, then you would not would not create a digital footprint that somebody could detect sort of the waves, and that provides an enormous level of security. So that therefore it is taken up in defense. It's taken up in areas where really security is very critical. So that's really taken up. And there's other applications, other niches, if you want, in industrialization for Industry 4.0, 5.0, where the technology is used commercially. It is used in aircraft in order to build sort of dense networks in aircraft. So there's various applications, various verticals where the technology is already taken up. And that's the typical innovation cycles that we see. New technology comes into specialized areas because of the cost, the scalability issue. But then as a next wave, we'll see the technology come into consumer as well. When sort of with volume, the price come down.
Yeah, I think that's an interesting point. I think we've noticed similar cycles with maybe the advent of lithium-ion batteries or maybe even graphene. It took maybe 2 to 3 decades for it to enter into the commercial market segment. Yeah, that's a very important point. So when you speak about defense applications, does LiFi allow for some kind of stealth mode to be established, especially when it comes to fighter aircrafts? Not just in terms of communication, but in terms of you not falling as part of the receiving radar.
I think it is a technology that allows communication in a stealth mode, if that is what you mean. It allows communication in a way that it's really difficult to intercept. It's very difficult to detect. It's very difficult to see, and yet we have the benefit of wireless data transmission to our intended user, and that's one of the key advantages of the technology.
Got it. So early on in this conversation, you actually mentioned about how mixed reality or virtual reality is sort of picking momentum, and that calls for higher requirements of bandwidth and connectivity, right. And LiFi should potentially cater to those requirements. So how do you sort of see this integration of LiFi based connectivity devices and the growth in the adoption of AR, VR, XR devices? Do you see sort of these two technologies being combined into singular devices that can be sold in the market, or do you sort of see it as standalone, connectivity domains different, and your devices that you're used to, experience these extended forms of reality is different, and you're just leveraging this higher connectivity to enable this?
Yeah. So what I think really is required, that this high-speed connectivity, which we called light antenna modules, these are communication devices that, because of the high frequency or the small wavelength of light, can be very small. You can conceive a light antenna module that is transmitting sort of gigabits of data, not bigger than the size of a camera module in your smartphone. So these modules, they can be integrated into AR, VR devices, achieving north of 10 gigabit per second. And if you look at the current sort of data requirements for sort of high definition, say 4K or 8K, and with a field of view of your AR, VR of say 30 degrees versus 17 degrees horizontal, vertically, then you would require at least 3 to 5 gigabit per second with compression of data. But if you extend the field of view, say 180 degree horizontally and 180 degree vertically, you would need really a substantially higher data rate, 10 gigabit per second, and that could be delivered by sort of light antenna modules that are integrated into AR, VR glasses, so that they are sort of inherent part of the device itself.
Yeah, the number that you mentioned about 10 gigabits per second is very interesting, because I was recently reading a report by Qualcomm on the connectivity requirements or the bandwidth requirements when it comes to AR, VR and stuff, and they were quoting similar numbers in the order of 5 to 10 gigabits per second for us to be able to have comfortable access to VR. Very interesting. So how do you sort of see maybe aspiring students or engineers and scientists contributing to this transition where LiFi is sort of the mode of communication or connectivity?
I think there's a lot of room for development, not only theoretically but also on the interface between sort of commercial use and prototyping, and I mean, there's so many great students out there, and what has to be recognized, however, is that this field of communications is evolving rapidly. I mean, the whole body of knowledge that has been sort of developed in the last 20 years on optical wireless communications and LiFi is enormous. And typically we don't see curricula that follow these sort of rapid changes in technology and understanding. So the students could and should, if they are interested in advanced technology, really use all different sources that are available to get to know all the recent advancements of the technology, because we see one of the major problems is a barrier of the uptake in the markets is that there's still a lot of misconceptions technically around the technology out there. And these misconceptions come through because of a fundamental lack of the theoretical and the foundational understanding of the technology. I'll give you one example. There's still a lot of people saying, okay, light communication doesn't work when there's strong ambient light, say sunlight, for example. It basically is saturating, and it is not allowing communication when there's sunlight. And that's not true. And that's simply not true, because we use advanced digital modulation techniques, which we call direct current optical OFDM, orthogonal frequency division multiplexing. That is a technique that is sort of robust against strong ambient light variations by the nature of the way it works. And therefore, we have shown that even with a strong sunlight in a detector, say 70,000 lux, you would still have very high data rates. There's a little bit of degradation that is accepted because of the additional shot noise that sun will produce. But other than that, the degradation is in the region of 5%. So it's marginal, and that's one of the examples where I think a full understanding of the technology would avoid people making wrong conclusions or wrong statement about the technology. And that's only one example. And the other example is about line of sight. You need line of sight. I mean, I can give you a number of examples where there's still the perceptions out in the public are often completely wrong. And that is because the field has been moved forward so quickly over a relatively short time, and it is a lot of catch up that people should be taking. So if somebody's really interested, really taking all the resources out there on the internet and really get a solid technical foundations of the technology.
Got it. I mean, since you mentioned about the line of sight, and this might be a very naive question, please pardon me for that. But earlier in this conversation, you mentioned about how light cannot pass through opaque mediums.
That's correct.
And that allows for a lot of security and other related stealth aspects to it. But we say that line of sight is not a mandatory requirement. How do these two actually find their place, coexist?
So that is a very good question. And then I think there's two things that I have to say. One is having a technology that works beyond sort of a room environment. Say you want to communicate in your room, and you have opaque walls, and that these opaque walls will block the light, so there's no communication beyond the wall, which is good. Higher security and also less interference. However, what I mean is you don't have to point like your TV remote control. You remember when you turn on your TV, you point the control into the TV to switch it on and switch it off. And that's pointed transmission. And that's what you would not need if you do the design right, if you operate within your room. So you're operating, you have your light sources that act as the access points, and then you have your phone, you turn it around in the way you turn it and use it with Wi-Fi, and you will not see a change in the service provision to the phone if you're not pointing it to your light source. And that's what I mean. It doesn't require that kind of line of sight. It also works of reflections in a room. It works of reflections and scattering.
Got it. So when it comes to radio-based communication or spectrum-based communication, I think India recently launched the 5G plan on a national scale, and I know of certain groups across the world that are working on maybe sixth generation of communication. What do these advents and progresses mean for LiFi?
I mean, 5G is great, and we're seeing 5G being rolled out worldwide. And there's one important development in 5G that we don't have to underestimate. It is the diversification of networks. If you look at 5G, there's three classes. There's enhanced mobile broadband. There's ultra low latency and ultra high reliable communications, and various other sort of strands of network designs that are geared towards specific use cases. And this segmentation of networks will increase. And therefore, there's an ideal sort of situation now when we talk about 6G, that we bring in with the LiFi to provide an additional network layer and application for highly secure, high bandwidth indoor use cases in indoor communications. So therefore, I think LiFi should clearly be one of the forefront technologies within 6G, while we bring it in 5G through various different use cases that I've described there earlier.
Got it. Might be quite an unrelated question, but why do you think Wi-Fi cannot live up to the standards of 6G?
I mean, first of all, 6G is a cellular standard, and Wi-Fi is sort of an IEEE standard. So one is 3GPP, the other one is IEEE. So basically different standardization bodies. Although sort of Wi-Fi is included in some sense within 5G. So the fundamental problem with for example Wi-Fi is that over many years there has not been new spectrum added to it. There's no new RF spectrum. So the US only recently has given additional spectrum for Wi-Fi last year or so in the 6 gigahertz region. So while the data rates in Wi-Fi increase, there is no provision of supply of the resources that are needed. That's why there's a lot of innovation in Wi-Fi around enhancing the efficiency of the use of the radio spectrum. So moving from 1024 QAM, quadruple amplitude modulation, to 4K QAM. So really squeezing in more bits within 1 hertz is the way that industry is going. But it is a limit, and it comes at a huge cost in terms of energy efficiency, and that's another major direction one has to consider. So there's a lack of spectrum, and there's also next year in 23 the World Radio Conference that is ought to identify new spectrum for 6G. It's still open where the spectrum is and whether it can be found in regions that are good for building cellular networks. So the problem is really that all the current cellular standards, be it IEEE or 3GPP, run in the same problem of providing the spectrum or having the spectrum to deliver these services. Again, having the roads and the highways that we need. But it is really important that in the optical domain, we have 2,600 times more unregulated free spectrum for exactly those highways that we need. And unlike terahertz communication, there exists a plethora of devices that have been developed for fiber comms that can be reused, that can be optimized for free space optical as well, rather than having to develop new devices there's still problems in terahertz about power output, about bandwidth, and so on. So there's really, it appears to be inevitable that one has to consider the optical spectrum for building future networks. Okay,
so when we talk about 6G primarily being about cellular standards, and when we talk about optical spectrums, do you think this allows for better communication in maybe mountainous regions or foresty regions where typically otherwise network connectivity has been an issue?
I think that's another area where this technology can play a major role, and are now deliberately moving gears from indoor access networks to outdoor backhaul networks. So really communicating across mountains, as you've said, and it's really hard and not commercially viable to basically dig up the ground and put fibers over mountains and into remote areas. But the digital divide is one of the major problems that the society faces right now, that there's the privileged people that have access to, say, gigabit internet, but there's the unprivileged in rural areas that don't aren't able to participate in e-health, in e-commerce, and so on. But it is possible also to use light to build point-to-point links sort of over, say, tens of kilometers, where the internet is beamed with light in free space rather than through a fiber cable. And that's free space optical communication. And there's a lot of development in this strand of technology using light as well. And there's an option again to help build extended networks with light.
Very interesting. So what do you think should anyone do to really accelerate how this happens? How the adoption of LiFi or optical based communication? How do you think this needs to come to life faster?
I think it is very important. I think we've been working in that technology for 20 years, and I'm really excited about it. We basically see the huge advantages, and it's sometimes heartbreaking that we can't move as fast as we want, because this field of communications technology is a rich ecosystem. So you have a lot of players that have to work together to make that entire ecosystem work. You have the devices, you have the materials, you have the system integrators, you have the operators, you have a lot of different people playing different parts on the entire ecosystem. And to get the ecosystem moving along and adopting the same excitement and seeing, sorry for the pun, but seeing the light at the end of the tunnel,
wow.
it is really, really hard. But it can't be done by us alone, and it requires other people to be equally excited to help us move along, and that's where I think we really have to do more work and hopefully galvanize and bring in more people that share the same excitement and help us along that journey. That's yeah, I can say here.
Very interesting. So this entire journey, it's probably one of those groundbreaking tech, like how back in 70s, 80s, 90s, World Wide Web was one of the groundbreaking innovations, and eventually, chip innovations were very predominant, and then more recently we were able to get to 3G, 4G, 5G, and so on. So this is probably one of those groundbreaking innovations that maybe takes years before it sees, like you said, light at the end of the tunnel. So what keeps you going through this? Like, what gives you the resilience to actually be obsessed about it when there are so many friction parameters?
Sorry, I didn't get the question. So
what keeps you obsessed about communication, LiFi,
right,
and bringing LiFi to life when there is a lot of friction for it?
I wouldn't say friction. It is stimulating to realize that we still have to convince many other stakeholders, but this is more of a challenge, and I as a researcher, innovator, I like challenges, and that's a challenge that we are taking on. So we are therefore still extremely excited to speak to people like yourself that help hopefully spread the message that really about the wonderful things that technology can do for society if we all rally around it and really help support it in whatever domain we are working in whatever field we are working in. But it's a joint effort that is required, but I think the benefits, if it's all rolled out, are tremendous, because it allows really exciting new applications that are otherwise not possible.
So you were mentioning about how there needs to be more awareness and perhaps more of incentive or reason for different stakeholders in the system to really jump onto this wagon. What do you think are some pressing reasons for existing internet service providers or governments or other communication device manufacturers? What's a good reason for them to jump onto this wagon? What do you think they're missing today that LiFi promises?
I think what is first of all, that's a very good question, and I think for us there's still a big job to do in order to educate people and stakeholders, because we have to understand that we are introducing a completely new technology in the sense of sort of wireless connectivity, where first of all there's been a lot of investment that went into radio-based wireless communications, and there's a lot of the drive in order to get better Wi-Fi, get better cellular, 5G and so on. There's priorities that the industry have in order to really monetize their investment, and therefore there's naturally probably not that much of a sort of a natural interest to scan and see what else is there that maybe in a medium to short term can really unlock completely new applications and completely new possibilities around, as I said earlier, AR, VR, digital twins, even sort of connectivity car to car and so on. And it's really the opportunity to showcase to people the benefits that the technology can bring because of the fact that there is so much spectrum that can be utilized, and the fact that there are existing devices out there, and the fact that people are talking about sensing is an important part of future communication application or future applications. People talk about LiDAR in cars. They talk about LiDAR into phones, and that's exactly the same devices, if you want, that we also use in LiFi. So there's a discussion to be had in order to using possible new estate that come into smartphones in a more intelligent and very powerful way. I can give you another example where we've driven the technology, and that's, we haven't covered it here, is in the energy efficiency that I've mentioned earlier. We can't spend more energy on building cellular networks. It already consumes more than the entire air traffic of all the base stations and all the infrastructure that's required. It has to be more energy efficient. And again, light has a big advantage and great opportunities here, because we can use solar cells not only for harvesting the ambient light, but also to act as a data receiver for LiFi. And we've done some work on that for many years. And you mentioned my second TED talk in 2015 that was exactly about off-the-shelf solar panels as high-speed data detectors. And now if you come back to your example about the remote areas, now we can build communication equipment that even don't need to be connected to the power grid. So you can even hang a sort of a FSO relay into a tree and have a multi-hop mesh network that spreads the internet like a nerve in your body through various parts of the environment that need to have connectivity. So these are opportunities that are out there, and I think it's for us maybe to have a platform to educate and to share the opportunities with people that are part of that ecosystem I've mentioned earlier, that we need to galvanize, that we need to bring on board to make the whole vision work.
Very interesting. And I really was intrigued by the point you mentioned about mesh networks. So I think there's a lot of work happening, probably in the very nascent stages, about building mesh networks of public hotspots and internet. Just about imagine you travel to any part of the world, any corner of the world, you have connectivity. I think that's potentially one of the requirements, especially when we're talking about education primarily becoming online, commerce going online, and stuff like that. So, in your opinion, what's the best way to build such a mesh network of connectivity across the country, across the world? How should it be done? And let's say when we're talking about using LiFi as a technology, does it allow you to share bandwidth across multiple users? For instance, if I have one router, one access point of Wi-Fi available, I could have many devices connecting to the same router. Can you allow bandwidth sharing across multiple devices when it comes to Li-Fi based tech?
No, I think it's important. Maybe to your first question, how to make sure that we can build mesh networks, and there's various attempts to build sort of global coverage with satellites, for example, and there's a lot of investment that goes into satellites to build sort of kind of mesh networks in space, which is great. But we have to recognize that a large part of the planet is covered by water and doesn't need data at the density that you require in a big city like Mumbai or Delhi or whatever. So there's therefore, and also you have that higher distances which come with delays. And if you talk about sort of delay intolerant applications, you can't use it via satellite. So there's an argument of building an infrastructure on terrestrial infrastructures and build mesh networks on the ground. And again, we can use fiber, and fiber is a great technology, but in many cases in beyond the big cities, in rural areas, there's no business case for the expensive deployment of fiber. Right. And there's free space optics that can really build a nervous system for these grounds, and that's certainly something that has to be considered.
Got it. And I think this very well ties with your earlier point on long range connectivity. So maybe there's a middle partly developed town, which is maybe 10 to 15 kilometers from a very rural place, but you could have your infrastructure in this town and still transmit some level of connectivity to the rural area.
That's correct. So that is really an important piece of a future infrastructure development. But coming back to your question about spectrum sharing, and now coming back into a home environment where we have Wi-Fi, and as you say, you're correctly right to say that a Wi-Fi access point has to share the radio frequency spectrum among many users, and in fact, increasing number of users. I think there's an average of 4 devices per person on the planet now that require wireless connectivity, and that is set to increase. And sharing means that per device you have less bandwidth and less data rate, and that's the nature of the beast in radio comms. But you can build because light is very sort of direct. Light is like giving light cones, and if you take that light cone to the extreme, you think of your laser pointer that you use to point to your PowerPoint presentation, and that little spot that you create on the wall, it could be a communication cell. So you could bring the coverage down to a sort of a spot. And with light, you can use simple optics, simple lenses in order to change your spot sizes as you like, and therefore you can create a sort of an access point that covers different areas of a room, and so people and use cases and devices could basically get their own private communication cell, so that there is no sharing needed. So every device in a room can have the same bandwidth that is provided by the source with light, and that's why there's a great advantage of the technology to enhance the data density, that's the bits per second per square meter, by orders of magnitude, and that's an additional benefit light communication will bring compared to nascent, as you say, or incumbent technologies like RF.
Very interesting. So you're saying that the directionality of the source here, which is light itself, allows us for spatial interference to have
spatial reuse of the same.
Yeah, very interesting. That should. Yeah, I mean, if you look at places like offices or workplaces, where you might want to sort of dedicate a certain amount of bandwidth to a certain place, and depending on the size of the cabin or the cubicle, I think this must have a lot of use cases.
That's correct. You could have a central access point, LiFi access point, that basically shines a beam on a cubicle in an office environment. And that is the data rate that's provided to that person sitting in this cubicle, and no one else will share it because it's only covering that area.
Very interesting. This kind of paints a picture of some kind of sci-fi movie scene in my head, but it's very interesting. Would be lovely to see how this pans out. What's the timeline you visualize for this to become a reality before LiFi is the mode of communication and connectivity across homes and workplaces?
I think that's a very good question. And as I said earlier, we have that technology already deployed in niche verticals. For the mass market, I think a very important step is the integration into the smartphone or into a mobile device, and that could be either via a sleeve that is LiFi enabled, or via a dongle, or via an integrated module. And it is, I know there's a lot of development in that area, and so once we see that integrated, I mean, that will unlock those new applications I've spoken about. So, I mean, it's imminent, and I would say, I think certainly, I mean, within the next couple of years, we'll see a major change in sort of consumer uptake of that technology.
Very interesting. I'd maybe take a step outside of this and ask you a much broader question around what do you think is just the future of communication and not just connectivity? Like maybe in 2030, 40, 50, how do you see the world communicating?
I think it is a very, very difficult but a very, very exciting question, and really, maybe if we look back 20 years from now, where were we 20 years ago? I say around 2000. So this was the time when we moved from circuit switched communication, so voice communication, to more mobile internet. We didn't have the smartphone that time. We didn't have the smart devices. It was primarily voice calls that were taken by a phone. And now see where we are. Basically, packet data. We have data rates up to 1 gigabit per second. At that time, we had data rates of 50 kilobit per second. And more. So we have increased the data rate, and we have substantially improved the performance. Now, 20 years from now, we'll see this trend moving further. But what will be, in my view, a massive changes is the connectivity between machines. So far, it's all human-centric. It's all social media. It's all people using the internet for YouTube and all the video sharing, and that consumes a lot of data. But we'll see in the future machines that do exactly their social media as well, but at data rates even higher because they need much more information. Think about an autonomous car. It needs gigabyte of data offload and download per day. An aircraft, gigabytes and terabytes of data. I mean, all these autonomous systems require a lot of data. So we will see basically an explosion of autonomous systems that require connectivity, that make our home world to really allow our world to get smarter with our robots that assist us. And we've seen just recently a robot being showcased in Silicon Valley, a humanoid robot, And that's the way to go. We need robotics, but in order to have all this working, we need connectivity. We need a nervous system, not only inside a robot, but between robots and the environment. And therefore connectivity is a critical part of the infrastructure that has to be developed. And if we don't do that, we can't really move forward in our digital societies and in a way that the potential is there.
So if I were to broadly condense this, you think Internet of Things is going to blow up and become the go-to kind of tech?
Yeah, it's the same thing that people say Internet of Things has been discussed for a long time. It's not taking up.
Yeah.
People have to be patient because these are paradigm-shifting developments, and they don't come overnight. It needs an entire it needs a big elephant to move in order to make things work that are so exciting, like the Internet of Things. But it will come. It is inevitable if we really want to get a smarter world and a world that consumes less energy and makes better use of current resources, where we can remove sort of traveling of masses like people, and instead have an experience of telepresence in a conference or so, that we online share the same experience as if we were there physically. And that mapping of the physical world and the cyber world, that requires resources, that requires the enormous developments on communication infrastructure, as in AI, as in sensor technology, and in robotics, and that's all joined up. It's not different. It's not separate items. These are very connected things that have to be moved forward jointly. And sometimes I'm afraid I need to say, sometimes people see communication infrastructure as a commodity, something, okay, we'll take some Wi-Fi router and then things work. It doesn't. It requires tremendous efforts.
Got it. So how do you see maybe, brain-computer interfacing or tapping into the nervous electric impulses and sort of using that as a mode of communicating with things around?
I think that's another really important area where connectivity is required. And we have seen there's work done by colleagues in Stanford, where they have put in sort of vision sensors at the retina and allowed blind people to see again, and now working on feeding sort of the sensor data of a camera sensor into the nervous system of a human. And also there's a lot of work in my direct environment with colleagues at the University of Strathclyde. They're building now a sort of interfaces between the nervous system and visible light communication by tapping into the nervous system with light, and that is an exciting area of using the technology to really help in e-health and provide better solve a lot of fundamental questions around broken issues in the nervous system of living species.
Very interesting. I mean, this entire discussion brings me back to one thought that I was having recently. We spoke about how you could capture images or audio and video and sound through pressure waves, and of course haptics when it comes to the robots. But one thing that I think has for long been under-recognized is, how do you really capture smell or transmit smell? Do you have any thoughts on that? It's just a wild thought.
I think again, it's a connected ecosystem of joint technologies, and smell is by sensor technologies, advancing sensor technologies that can basically identify particular molecules in the air and translate that to electrical signals. But if you have, smell is there's sort of billions of molecules in the air, and it has to be, they have to be detected separately and also jointly, and there's a lot of technology required, but also the sheer amount of different input data on different types of molecules to convert that and transmit that requires, again, big data channels to do that. And but I think it's all possible, and it's we have gas sensors out there, but very, very rudimentary at the moment, and there's another, and this is another area of great research that needs to be done.
Very interesting. So you think with VR and extended reality in place, the next time we are in a conversation, we're going to feel more physically closer.
Yes, absolutely. Feel physically closer, and that is really coming through this sort of merger between physical and cyber worlds, and that's where the world is going, and where there's a lot of potential for innovation.
Very interesting. Maybe slightly off tracking, but I think you must be one of those few academicians who is also maybe full-time entrepreneurs and working at the close intersection of both the worlds of academia and I wouldn't even call it industry. Let's just say startups and innovation. What brings you? What do you find sweet about this particular spot that most other academicians do not?
What I personally find really exciting is allowing out of the box thinking and trying out things that are against the odds, if you want, that are not within mainstream of work, which are sort of free ideas that can be tested and allowing new ideas to be developed and tested and brought to society to help solve some of the fundamental challenges that humanity faces. And this is where I see as an engineer, and we, as an engineer, basically we have to. That's where things have been developed over many years, is really changing the quality of life of people. And engineering has done such a great job in doing that. I mean, life expectancy 100 years ago was substantially lower than it is now. And engineering has done a lot to help expand life expectancy. And so really, that is what drives me, taking engineering, taking ideas and trying to turn the ideas into something useful that touches everybody in a sense. And that's where this translational element of the work, this is really where I'm excited. And I mean, I've spent a lot of time in industry. I've understood the limitations of industry. I've spent a lot of time in academia. I understand the limitations of academia. And now I want to take the limitations of both and make those into something extremely positive and game changing. And that's what I've tried to do with the opportunities I've been given.
So would you want to elaborate a little bit more on what do you think are key limitations of both the academia and industries today?
I mean, I'll give you my frank view here. So industry has to be very product oriented, very revenue oriented. It has to be very strategic in a sense what industry can do, and the industry has to understand really where they play in the market and gear everything towards one narrative in terms of making the product the industry is selling a success. That's a very narrative, and therefore many things in terms of out of the box thinking often are excluded because they don't feed into that narrative. I mean, there's examples with other companies that give employees more freedom, but that's only possible if you have a huge company that has the resources to allow that freedom. But if you talk about a smaller company, it has to be focused around a product. That limits naturally a few things that can be done. On the other hand, academia allows exactly that out of the box, the blue sky thinking, coming up with radically new ideas, and academia comes up with these ideas, but academia is measured on the amount of new ideas that are produced, and therefore you see that cycle of having a new idea, testing it, finding the analysis around it, and publish a paper, and then publish in a high impact journal paper, and once that is published, go back to the next idea and test it and do another paper. But really, it stays within this sort of incentive cycle of academia. What I've been trying to do is basically take the freedom of academia, write the research papers and have high impact research papers, but then take also the next steps in stepping up the technology readiness level to prototypes and then even founding a company and trying to get it into the markets. But really, this translation of fundamental ideas and sometimes really blue sky ideas and also ideas that may not work, but really this exciting new translation activities is something that excites me, and that's working across those interfaces, and hope I've explained these limitations, and I try to make them create them an advantage.
Yeah, I think one of the often stated things about research is there's probably not enough funding for ideas to really turn into products and realities. Do you think that's in any way a hindrance? And if so, what's really the right narrative or the approach to really modify how the incentive cycle works?
I think you're absolutely right, and I'm basically I have a good side of the UK academic system, and that's one of the fundamental problems and a lost opportunities on large scale. As you rightly say, I mean, there's research funding for low TRL research, so really the papers and so on, but there's no real investment for translational research, really taking the ideas and really doing the hard engineering and prototyping and putting it out into the fields and learn by deploying in the field. And basically finding out what's the commercial value rather than writing a business plan and saying my protection based on volumes in the market and without realizing what the addressable and market really is. It's all stupid in my view. Writing these business plans is really taking our ideas and test it with real communities, but that requires resources and that's the other part that I've mentioned. We need to have this ecosystem coming together, and I wish there's more venture capitalists that have a more risk appetite that would say, okay, that's a great idea, and we support some of these translational work and see where it goes, recognizing it's a high risk, but also a extremely high reward. And getting funding into that translational work is really, really difficult because it's not part of the traditional sort of funding sort of society or ecosystem.
Yeah, I think there needs to be a lot of collective effort from maybe industries, academicians, governments, venture capitalists, and a lot more, probably just betting on the idea of a better future.
That's absolutely correct.
Yeah. So before we really conclude, one question here, like what would you do for a career if you were 20 years old today?
I think that's a very good question, and I mean, in hindsight, there's a lot of learning. If I take the learning that I've taken over the last 20 years or 30 years and take that into new approaches, is I would be more bold and having more confidence, if you want, in trying new ideas and have the, as I said, confidence to try to change the world early on. Sometimes when you're young, you look up to the big sort of professors up there, the big industrialists that have allegedly run big businesses and anything. Oh, I aspire to be like this and this. But the fact is, everybody can change the world even at very young age. And if they believe in what they do, and have a bold vision that they believe in and make it work. So really everybody should have, in my view, the courage to try out new radical things and try, if they aspire to do so, if they want to change the world and have the ideas, they should go for it and not wait until maybe things happen. But really, everybody has the power to change things at any age. I would believe.
Very interesting. I mean, now that you talk a lot about having the audacity or the courage to change the world and bring paradigm shifts in how we perceive things, one of the, I think, often overused terms is the word called change maker. And this mostly stems from, I would say, a social standpoint, but not as much on the technological standpoint. And maybe as much as people talk about innovation, they probably do not play active part in how it really pans out. So, like, what do you think is one myth when it comes to innovation that people fail to understand about innovation in general?
I think a myth about innovation is, it's an extremely good question. There's a few things that are important about innovation, and really what I would call innovation that has an impact. And typically, it is really hard to game change things. It is relatively straightforward not straightforward, but it is easier to have an idea and have a new idea, but taking it through to the end user and really trying to create the impact, if it's a radically new idea, requires a lot of effort, and maybe there's an underestimation in terms of the effort that is required to innovate in an impactful way. And there's a lot of work that is needed in galvanizing people around oneself to help drive a vision and to basically broaden a vision that is basically sits within one person and make it a vision of others, if you see what I mean, and bringing people along a path that is necessary it's necessary to go and getting the support from all different angles towards that vision. And that's maybe one of the big myth or challenges and oversights that innovators may see, is the effort in terms of taking others along that path and basically making convincing arguments for stakeholders to follow that vision.
Yeah, so basically how you tell your story is as important as what your story is.
It's to tell it, but it's beyond that, to convince and basically make the vision, your vision, the vision, or others adopting that vision as their own, so that they also are ambassadors of your vision. So and achieving that is a challenge on its own. But if it's possible to achieve that, then I think there's a greater chance of an innovation to really have a long-lasting big impact.
Interesting. And what's one last piece of advice you would give to someone in their early 20s today?
Again, if you're convinced of something, that you're truly convinced by your heart, not by, I think I have to do this because if I do this, I get rich. No, that's the wrong motivation. If you believe of something in your heart and you see it's not maybe easy to realize, is just believe in it and work with others and follow it through and don't give up. And that's really what I would say.
Interesting. And I mean, especially someone in their youth, maybe early 20s, who do not have much of experience. Do you think credibility comes in the way of realizing their ideas? And if so, how is someone to really communicate their ideas and convince maybe experts like you and bring you along the vision?
I think the way to do it is really speak to people, to come out and explain what the benefits are and what that new innovation could achieve, and showing that the innovation works, first of all, but really going out and using social media, using platforms to spread the idea and galvanize people. And that's, I mean, it's a hard thing to do, but it is very rewarding. And because it's hard, that's why I said it's important if one believes in it, not to give up, because there is always backslash. There's always people who say exactly the opposite. There's always people that want to bring ideas down for whatever reasons, and just withstand that and believe and go with what people think it's important, right in their own heart.
Got it. Thanks, Professor Harald. I think this discussion has been very insightful for me. Got to learn some really cool stuff about communication, connectivity, and how you see the world in maybe 10, 20, 30 years from now. Thanks a lot for doing this with me, and I really wish and hope that LiFi is in my home soon.
I do hope so as well, and it's been a great pleasure to be on your podcast, and I really enjoyed the conversation. Thank you very much.
Thank you, Professor Harald.